All right, class, now we're doing the notes for section 4.3 for unit 8. Is the relationship linear or not? Okay, so linear relationship is a relationship in which when you graph it, it's going to make a line. Well, if it makes a line, that means it has to have a slope on the table. So whether we're looking at a table or a straight line, obviously a straight line, if you're looking at a graph, you would know is linear. But specifically when you're looking at a table, you want to see, is it actually have a constant slope throughout the table? Okay, so we have this table here. So what we want to do is we want to find the slope and see if it's constant or not. Okay, so I'm going to look from one point to the next. Notice I'm comparing time with distance. Okay, and knowing what we know about independent and dependent, the distance would depend on the time. The time is always my independent, so that's like my x, and my distance is like my y. Okay, so I want to look at how are these changing. So I'm noticing from 1 to 3, my x's are going up 2 there. Then from 3 to 5, also going up 2. Then from 5 to 10, this time it's going up 5. So sometimes people automatically see those different numbers and think, oh wait, this can't be linear because that's going up at different amounts. But what we have to do is, slope is not just how are my x's or my y's changing, it's how my y's over my x's, right? Because that's my rise over my run. So let's look at these now. Let's look from 9 to 17. That would be an increase of 8. From 17 to 25, also an increase of 8. And from 25 to 45, that's an increase of 20. Okay, so we're noticing something. So the 2's and the 8's, those happen to be the same. Then this is a bigger number, and so is this. So this just might be linear because as I find my slope again is my rise over my run, which is my change in my y's compared to my x's, right? The y's go rise and your x's run. So as I look at these numbers, first look at my first change. It goes up 8, a rise of 8, and a run of 2. So 8 over 2 would be my slope of my first pair. Okay, my next pair is the same. It's also 8 over 2. So we do know, in fact, those are both equal, right? So then we look at the last change. It goes up 20 for every 5 hours there. So it's a rise of 20 over 5. Okay, well, if I look at those, 8 over 2, that's 4. 8 over 2, again, is 4. 20 over 5, divide that, is 4. So you'll notice that, every single rise over run or change in y's over x's does simplify down to the exact same slope. Okay, so for the question, does this table represent a linear relationship? We would say yes, because the slope or rate of change is a constant 4 miles for every 1 hour. Notice that's what we were dividing is miles over hours. So it's actually 4 miles for every 1 hour. All right, so then it does say, if so, write an equation for the relationship. Okay, so if we're going to write an equation, we know it's going to be y equals, and then we would put the slope, which the slope was 4. So we'd say 4x plus then our y-intercept. So we'd have to think about what would be with 0. So notice again, the table does not have a 0 in it. So if I were to put a 0, that would obviously go above the 1 here. Okay, well, if it's going up 4 for every 1 hour, I would just have to think backwards. If I'm at 9 here and it's going up by 4 every hour, I would just have to think 4 before that. So 4 before that, take away 4 from 9 would be 5. Okay, so I would have a starting amount of 5 miles at 0 hours. And then if I keep going up by 4 every hour, it would then fill in this chart. Okay, so that would be my equation. Again, the number with the x, that is my slope. The other number is my y-intercept or my starting amount. All right, and that's it for your 4.3 notes.